Hello, it's time for another IGCSE Marine video, this time on a short section 2.6, which is about upwelling and El Nino oscillation. As always, any mistakes here are mine and mine alone and does not reflect in Cambridge. This is made for my class, but if anyone else can use it, they're more than welcome to. Everything here is non-profit. So, one of the big issues when we look out in the open ocean is that on top we have the sunlight, we have the CO2, we have the hot temperature, we have everything plants need for growing, well, everything except the nutrients. The nutrients, which are like the magnesium, the calcium, the iron, the nitrate, the phosphorus, all that, that will, out in the open ocean, sink to the bottom in the form of marine snow and other detritus, which means we have everything we need for algae growth except the nutrients, which means that the primary production is often quite small in the middle of the open ocean. When we then have what we call upwelling, we have a dramatic increase in our primary production. Upwelling is when we have warm surface water moving away, usually from a coast, then the cold bottom water comes up, and in that cold bottom water we have the nutrients, which then can lead to algae growth. We have also sometimes when we have ocean currents, which will then hit something, and when it hits something, that cold bottom water gets to the surface, and that leads to an enrichment of the surface water with nutrients, and then we see a growth in algae growth. When we have more phytoplankton, we get more zooplankton. When we got more zooplankton, we get more of the small vertebrates, more small vertebrates, more of the bigger vertebrates. This boosts the entire food chain. Now, in our southern Pacific Ocean, we have something we call El Niño, Spanish for the child, in reference to baby Jesus, and that's warm surface current that occurs periodically around Christmas, hence the child. And when we have El Niño, as I'll show you later, we'll have less upwelling than we'll normally have. So here we see an illustration of what we call normal conditions for the southern Pacific. We have the wind blowing so that we don't have a fixed thermocline next to the coast of Chile and next to the coast of California. That means we will have a upwelling because the wind blows away from land. So we'll have a upwelling and we'll have cold water coming up. This will of course affect the weather systems. There'll be less rain here on the coast than usually. But it also means we'll have a high primary production. And if you are a fisherman living here, that will give rise to a very productive fishery. And if you are, for example, a blue whale or someone else who, the big whales swim around for eating, having a high amount of upwelling will lead to large production of small crustaceans and so on. So it will boost the entire food chain. As we see here, that will also tend to give us a weather system where we'll see we have warm water around Australia, which also leads to rain in Australia. Now, under El Niño conditions, the warm water moves further towards South America. This gives us a very fixed thermocline as we have the warm water lying on top because it has a lower density, and then we have the colder water with a higher density further down. This gives us very little upwelling because now we have a fixed thermocline, so all the nutrient-rich water at the bottom stays at the bottom. This leads to a much lower primary production, and this, of course, gives less energy up the food chain. It also changes the weather system, so we have more rain along the coast of Chile, around South America, and we'll have more dry and hot weather around Australia, which can lead to brush fires and other incidents. We also have the opposite effect called La Niña. La Niña is the opposite of El Niño, and here we have a strong wind that blows away from the coast along the Pacific Ocean of equatorial Americans. This will lead to a larger blob of cold water here, which leads to way more upwelling, way higher primary production, and also different weather systems here. So we usually see a fluctuation between El Nino and La Nina years. That is kind of the natural system. So having years with El Nino is nothing unusual. It's always been that way in the Pacific. But even though changes between the El Nino and La Nina are natural, as we can see in a map here, where we kind of try to map these from 1950 to 2000, we tend to see a trend going towards more El Niños and fewer El Niñas, and this might be due to global warming of our oceans. This is only up to 2000. I guess if I found a newer one, we'll see the even more strong effect of the warming ocean. So this means that heating up the ocean will also change the patterns of how nutrients get recycled, how upwelling works, and of course how the rain, the weather systems will affect the land in Australia and South America. So just to sum it up, in normal conditions, we'll tend to have the warmer water further out west, the colder water east, which then gives rise to wind going towards Australia, which then means we have not a strong thermocline at the coast, and which gives us upwelling. While when we have El Nino conditions, the warmer water flows eastward, we have a fixed thermocline, and we don't have the same amount of upwelling.